Hey, welcome back to our next lesson. Today's lesson is all about distance. A really important thing to be able to do is find distance, especially since we're talking about graphing and plotting coordinates, because when we plot points, they're very helpful to represent locations. So you can imagine there's so many applications and uses for a coordinate plane. So our mindset message for today is that struggling grows your brain. I chose this today because I'll just tell you right off the bat, this can be a challenging lesson for a lot of students. So you can do it, just stick with it. What I'm going to say though is you really need to pay attention to the definitions that we introduce and the vocabulary and the meaning behind stuff today. To actually understand how to apply the stuff we're going to do, you really need to focus on the meaning, okay? Our learning goals, first, basically just to understand absolute value. Many of you are probably familiar with it already, and if you're not, that's okay. We'll start from scratch. We will want to be able to, or need to be able to, solve absolute value equations. And then the last main thing is finding the distance between 2 points in the coordinate plane. Prior knowledge, you need to be able to find distance on a number line and just plot points on a number line in general, okay? You also need to be able to plot points in a coordinate plane, and then a theorem that you should have learned normally in 8th grade, I think, would be the Pythagorean theorem. That helps us relate the sides of a right triangle. We will review it briefly, but you may want to go do more review, do a YouTube search or something like that, okay? So let's go ahead and dive right in. Our first question I'm going to ask is a pretty basic one. How far away is the number 3 from 8? What I want you to do is just record in your notes however you figured this out. And the fact that you've done just a little bit of thinking, I know this isn't a very complicated question, but will help us lay the foundation for the rest of what we're going to do. So there's likely 2 main ways that you might have thought of this. What I want you to do is make sure that you've got both of these in your notes and recorded, because they're both going to be important ways of thinking about things today. So you could have used the number line or just kind of thought in your head, what is the actual distance? You can realize 3 to 8 is 1, 2, 3, 4, 5 units away, right? So the distance from 3 to 8 is 5. You may have also thought about it by subtraction, because if we take the larger minus the smaller number, then you get the distance away, right? So 8 minus 3 gave me 5. Both of those ways are perfect ways, and they're both really important ways of helping us understand distance. So just to put this into practice real quick for yourself, go ahead and do these on your own, just like we did the last one. Use a number line and subtraction to find the distance between each pair of numbers. Let's take a look at these together. So again, we have 5 and 12, and the distance is 7. The subtraction is 12 minus 5, which is 7. Now remember, you'll notice that each of these, you know the higher number goes on the right and the lower number on the left. And same here, when you do the subtraction, the higher number is first, and then you subtract the lower number away from that, okay? So this one's interesting because 0 to 12 kind of seems obvious the distance is 12 because 0 doesn't have any effect on that total thing. So that just is 12. This one might have been a little tricky. If this is -3 and this is 12, one thing to think about here, this is how I often do these, is I'll think about where is 0? 0 is somewhere down here, let's say. And if from -3 to 0, we know that's a distance of 3. And from 0 to 12, like we thought about there, that's 12. And together, that 3 and 12 make 15. So that's an important way to think about that. Now again, this is a little trickier because when we do the larger minus the smaller number, 12 minus -3, if you recall, when we subtract a negative, it's equivalent to adding. So that becomes 12 plus 3, which is 15. It may have been confusing because if you did the subtraction wrong on accident, maybe you didn't get the same answer. But this is how that should work out. This is all fine and dandy, but there's a little bit of a problem that we're going to talk about next. So let's take a look at that. So, as we've stated, the distance between two numbers is always the larger number minus the smaller number, right? Yeah, that's perfectly true. But in algebra, we're often working with numbers and values that are unknown. So if I don't know one of the numbers or both of the numbers, what do? Right? Often the numbers are unknown. So if they're unknown and I still want to represent their distance somehow, it's hard because I can't just write a subtraction if I don't know which number is larger, right? So for number 3 here, for two numbers A and B, how far apart are they? Which one is bigger? You might be tempted just to say the second number is bigger, or B or something, but that's not necessarily true, right? Since they are actually variables and they're unknown, we don't know in the moment. So this is where mathematicians do some nice stuff. They do some exploring, and then they invent new notation to represent an idea that they need. So let's step through that together and work through this question with each other. So as I said, the first thing that mathematicians do is explore. So we're going to explore an idea. Remember how we said it's always the larger minus the smaller? And I'm going to reuse the same pairs of numbers we did in the last example. But what if we just did the smaller minus the larger? Do we notice anything that happens? Those are the kinds of questions mathematicians ask. What if I try this? What if I see what happens here? So here's the correct way that we did it, right? But watch what happens. What's 5 minus 12? That's negative 7. 0 minus 12 is negative 12. And negative 3 minus 12 is negative 15. I want you to look really carefully at each of these numbers here and each of these numbers here. So look at those and how they compare to these. If we reverse the order of the subtraction, what happens to the outcome? It turns out these are just the exact opposite. So if we reverse the subtraction, A minus B is the opposite of B minus A. And that's always true. Let's actually look at a very quick proof using distribution of this. So we're going to prove it. You know, if somebody doesn't believe you and they want you to convince them, they'll say, prove it. So we're going to convince ourselves that it's not just these random examples that this worked for. Okay? So if we take A minus B, well, what does it mean to take the opposite of something? The opposite just means the negative, right? So if I apply a negative to A minus B, let's actually see what happens. Well, you and I both know that this distributes in there. And if you want, you can think of a negative 1 multiplying in, okay? But what happens is negative A minus negative B, right? That negative distributes in. So this becomes a minus negative B. Well, this becomes negative A, and we know that a double negative makes addition. And then now we have negative A plus B, but we know that addition, we can swap around the things, right? And so negative A plus B is the same as B plus negative A, which of course is just saying B minus A. So look very carefully at this and watch what happened here. What this tells me is the opposite of A minus B is the same as B minus A. So I'm going to say this in words. The opposite of A minus B is B minus A. That's what we just showed here by doing these steps. Now, why is this all important in the first place? Well, it turns out to be very helpful because if these really are the same number, so remember, we said larger minus smaller must be the distance. But if we do smaller minus larger, and the only difference is just that one of them is positive and one of them is negative, we can make a little quick fix to that. And this leads into absolute value. All right, we're finally at our most important definition of the day. And when I said earlier, it's really important that you pay attention to this definition and that the rest of what we do, you really focused on its meaning. I really meant that. So our new notation, here's the setup. We learned that a minus b and b minus a are always the same, except they're opposites of each other. So if one of them is positive 3, the other one's going to be negative 3, right? But because distance always must be positive, right? We can't just subtract the two numbers and say that's a distance, because a distance has to be positive. That's why we said larger minus smaller before, because that will make it stay positive. But again, if it's unknown, we need a symbol to basically say, make it positive, right? And this is where we invent new notation. That's how math works. You explore, and then when you need something new, you gotta invent it. The absolute value of a and b can be written as either bars, a minus b, or b minus a. So it has these two straight bars on the outside, and when you see that, you need to read absolute value. This means the distance from A to B. So when you see this, this is the absolute value of A minus B. You can read it that way, but actually when you see that, what I want you to actually think in your head, as soon as you see absolute value, I want you to think the distance from this to this. Now it's important that this is subtraction. We'll talk about how to deal with it if you see addition inside of an absolute value later on, okay? But for now, this means the distance from A to B. This one technically says the distance from B to A, right? But we know that the distance from A to B or B to A is going to be the same. It doesn't really matter if I walk forwards or backwards. The distance is always positive, and of course that's going to be the same. So now that we know this, now I did this in red on purpose, because this red is exactly the same meaning as this, which is the exact same meaning as that. So I'm going to take that, make sure you have that written in a very important place, tuck it in your pockets because we're going to use it. Okay, so let's directly apply our new definition. We want to write a sentence describing each distance and then find that distance. So you notice this has a minus and it has absolute value. So this is really saying the distance from -3 to 8. It's really important that you read this properly. This is saying a distance, and it's saying the distance from this number to this number, but that minus is part of the absolute value, okay? So even though this is a -3, that's just a regular 8, okay? Now, if you actually want to find that distance, you can do whatever you want. You can just think about -3 up to 8 and realize that that's going to have a distance of 11. You also could just evaluate this, and this is likely what you've probably seen if you've studied absolute value before. You've learned that you can just do this. -3 minus 8 gives me a -11, but then when you apply absolute value, we talked about we need something that means make it positive. Well, -11 is the negative version of the distance, but the actual distance is going to be 11. Does that make sense? So that's where that comes into play, but I want to try to avoid just thinking absolute value means make it positive. That's not a full definition of this. So it's better to make sure that your brain is now training itself to think distance, okay? So let's take a look at the next two right now. This is a problem. It has a plus, but we both know that we can rewrite this. 2 plus 5 is the same as 2 minus -5. So what's my new sentence? This is saying the distance from 2 to -5, right? And again, of course, if you just add 2 and 5, it becomes 7. And so we can see that this equals 7, of course. But again, don't forget that meaning. Now, this one, you may be like, Mr. Engel, all we got to do is realize, oh, and make it positive, it's going to equal 6. You're definitely right about that. But I do want you to not forget the meaning we came up with before. Technically, a -6, do you agree that that's the same as 0 minus 6, for example? So really this is saying, because we still didn't do the sentence, right? Really what this is saying is the distance from 0 to 6, right? Now here's a crazy thing. I'm just going to tell you, there's many choices that could be correct to make a -6 inside there. For example, couldn't I do 2 minus 8? Because 2 minus 8 does still give me a -6. And if I did that, this would be saying the distance from 2 to 8. And that's actually also correct. This represents, it could represent many distances because there's lots of pairs of numbers that have a distance of 6, right? So 2 to 8, 0 to 6, lots of choices. But either way, it's important you can translate and then actually figure out what that distance is. What I want you to do is finish off D, E, and F on your own right now, same instructions, and then we'll check the answers. So go ahead and pause. So let's see how you did. This guy here, the distance from 7 to 1. And of course, that distance from 7 to 1 is 6. This one here, be careful, it needs to be subtraction, so we have to rewrite it. And now it says the distance from 4 to -2. And of course, if you just add that and get 6, you'll know that that's 6. But don't forget what the meaning is, right? And if you were to make a number line, number lines are really important. Please make sure that you're thinking about those or even using those. Because if I'm saying the distance from 4 to -2, remember 0 is about right there. That's 2 and 4. That total distance is 6. Okay? Make sure you're understanding how to find distance there. And this one's a little trickier too because it has a negative and a plus. So this says the distance from -3 to -4. And actually those are right next to each other on the number line. As whole numbers, I mean. And so their distance is simply 1. Okay? So now that we have those tools in our belt, we can really get to an important thing. And next what we're going to learn to do is solve equations with a missing variable that involve absolute values.